Custom JavaScript injection, also known as JS inject, is a feature in EvilJinx that allows Phishlet developers to inject their own JavaScript code into the proxied pages. This capability opens up a wide range of possibilities for enhancing the phishing experience, bypassing client-side security measures, and dynamically interacting with the target website. In this section, we'll fully explain the custom JavaScript injection parameter, its features, how to use it effectively, and the reasoning behind its implementation. When working with JS Inject, you're dealing with code that lets you insert your own JavaScript into the target page. Trigger domains. This is where you specify all the domains that your JavaScript injection will be active on. You list them as an array of strings. So, if you want your script to work on multiple domains, you include each one in this list. Trigger paths. This parameter allows you to target specific URL paths using regular expressions. You can think of it as defining where on the site your script should execute. It gives you control over which pages your JavaScript will be injected into, allowing for more targeted actions. Trigger parameters. This is where you define specific parameters that must be present for the JavaScript injection to occur. It's like setting conditions that need to be met within the lure for your script to run. It ensures that the injection only happens when certain criteria are fulfilled. Script. This is the actual JavaScript code you want to inject. It's defined as a string and will be injected into the target page, typically right before the closing body tag. This is where you place the functionality you want to execute on the target page. JS Inject is a tool that allows for dynamic modifications to the page's appearance, behavior, and functionality. These changes help create a more convincing and targeted experience, increasing the effectiveness of the phishing attempt. JavaScript injection can be used for these particular things. Bypass client-side validation and security checks, allowing the page to avoid built-in security measures. Capture additional user input or data that isn't available through traditional form submissions. Manipulate DOM elements to hide or display specific content based on user interactions or certain conditions. Implement key logging functionality to gather more detailed information from the user. Integrate with external APIs or services, enhancing the attack by adding real-time data or additional features from various third-party services. We are looking at a typical example of how the JS inject parameter is used in the Phishlet configuration. This template provides the structure that most JavaScript injection scripts will follow within a Phishlet. Overall, this template provides a flexible way to customize the behavior of a Phishlet using JavaScript, enabling you to tailor the phishing experience to specific targets and scenarios. Next, we'll dive into more detail on the different components. The JS inject parameter in EvilJinx Phishlet configuration files allows for the injection of custom JavaScript code into specific parts of the target website. This is a feature that can be used to enhance phishing scenarios by dynamically interacting with the web page. Let's go over syntax and usage. Trigger domains. These are an array of domains where the JavaScript injection will be triggered. This can include the main domain and subdomains of the target website. Next is the trigger paths. This an array of URL paths where the injection will occur. This allows targeting specific pages or routes within the website. Trigger parameters are optional. It's the array of query parameters that must be present in the URL for the injection to be triggered. This enables conditional injection based on specific parameters. Then, the most important part is the script itself. This is the actual JavaScript code to be injected. It is typically written using a multi-line string syntax, which is indicated by the line character. For simple readability, this is where the custom code goes, enabling various interactions such as form manipulation or automated actions. You can do a lot of cool things with this. Here's some use cases for JavaScript injection using the JS inject function in EvilJinx. Keep in mind this is not a JavaScript course. This is simply how to use JS to customize phishing pages in a man-in-the-middle attack context. Here are some things you can do. Hide or modify page elements. JavaScript injection allows you to alter the appearance of a web page by hiding or modifying specific elements. This can be useful to remove any elements that might alert the user to suspicious activity or to modify the content in a way that makes the page more convincing. Dynamic content modification. With this use case, you can dynamically change the content on a web page based on user interactions or specific conditions. This capability helps in creating a more personalized experience, which can increase the likelihood of success. Bypass client-side validation. Client-side validation is often used to ensure that the data submitted in a form meets specific criteria. By injecting custom JavaScript, You can bypass these validations, allowing for the submission of data that would normally be rejected or altering the validation process to suit your needs. Capture additional user input. Beyond the standard credentials, like username and password, you can capture additional information by injecting JavaScript that monitors other input fields on the page. This could include security questions, personal identification numbers, PINs, or any other data the user might input. Monitor user activity. JavaScript injection allows you to monitor user activity on the page, such as mouse movements, clicks, and key presses. This data can be used to analyze user behavior or to trigger specific actions based on their interactions with the page. Implement custom redirection. You can control the flow of user navigation by implementing custom redirection. After the user submits a form or interacts with a specific element, you can redirect them to another page of your choice, guiding them through the phishing process or towards a malicious destination. Manipulate DOM elements. The document object model, DOM, represents the structure of a web page. With JavaScript injection, you can manipulate DOM elements to change the structure and behavior of the page in real time, making it behave in ways that support your phishing goals. Inject fake login forms. One of the most direct uses of JavaScript injection is to inject fake login forms into the web page. These forms can be designed to look exactly like the legitimate ones, tricking users into entering their credentials, which are then captured by the attacker. Change page variables. If a web page uses JavaScript variables to manage its behavior, you can inject code to modify these variables. This can change how the page operates, potentially exposing vulnerabilities or creating opportunities to capture sensitive information. Autofill form fields. This is probably the most popular use case and the most practical example of using JS inject. It's extremely effective. Familiarity in social engineering is like 50% of the puzzle and increases the odds of a user taking said action. This can streamline the phishing process by reducing the steps the user needs to take, making it easier for them to unwittingly submit their information. Create pop-ups or modal dialogues. JS injection can be used to create pop-ups or modal dialogues that guide the user through a specific process or prompt them to take a certain action, such as entering additional information or agreeing to terms that may compromise their security. Execute conditional actions. Finally, you can program it to execute actions only under certain conditions, such as when the user is logged in or after they've submitted a form. This conditional logic makes the phishing attempt more sophisticated and less likely to be detected. These are just some examples that I've used when using JS Inject. More things are possible depending on your expertise and creativity level. Let's discuss injection placement and execution. The injected code is inserted into the HTML of the proxied page. Typically, this happens right before the closing body tag. This placement ensures that the script runs after all the page elements have loaded, making it easier to interact with or manipulate the content. Execution triggers. The injected code is executed based on specific triggers. This could be when the page initially loads or when certain events or conditions are met. For example, it might trigger when a user clicks a button or submits a form. This flexibility allows you to control exactly when and how the script influences the page. Access to the DOM and JavaScript environment. Once the JavaScript is injected, it operates within the same document object model referred to as DOM and JavaScript environment as the original website. This means it has the ability to interact with page elements, modify content, and perform actions, just like any other script running on the site. This level of access is what makes it effective for creating dynamic pages. Here are some key considerations when using the JS Inject feature. Custom JavaScript injection requires a good understanding of JavaScript and web development concepts to implement effectively. You don't have to be an expert, but you should understand the language well enough before writing the code. That being said, you could just GPT custom JS inject code, but I find that this is not effective in practice, at least most of the times I've tried. For some reason, LLM Assistance doesn't understand deeply enough how to generate custom JS for EvilJinx. It just spits out nonsense that on paper looks fine, but when you load it up, it doesn't work properly. Injected code should be crafted and tested to ensure compatibility with the target website and avoid unintended consequences or errors. The injected code should be executed in the context of the phishing page and may be subject to the same security restrictions and limitations imposed by the browser or the website's content security policy.